darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. They appear out of nowhere and threaten our very existence. From rocks crashing through homes to Mount Everest-sized boulders triggering mass annihilation, no one is safe from their wrath. And some of these intruders are not extraterrestrial. They're actually man-made cosmic junk. Take cover as we investigate meteorites and space debris, the deadly stuff that falls from space. "11:39 p.m., October 6th, 2008. The Catalina Sky Observatory in Arizona notices something it hadn't seen before. An asteroid the size of an SUV is screaming down towards Earth at over 27,000 miles per hour. An alarm sounds throughout the international scientific community. Is this asteroid on a collision course with Earth?
This object was special because it was probably going to impact the Earth. And over the course of the next 21 hours, 500 observations were made of the object to try to exactly calculate its orbit.
At NASA's Jet Propulsion Laboratory, Steve Chesley gets the urgent wake-up call. Everyone wants to know when and where this rock will touch ground.
They sent me the data. I rushed into the office rather excitedly and spent the next couple of hours trying to get my arms around the problem and running the numbers. And I reached the conclusion it was a 100% chance of impact.
Chesley calculates the collision will occur in less than 13 hours, approximately 5:45 a.m. Eastern African time. Its target, the Nubian Desert in northern Sudan.
We hadn't really expected or anticipated the discovery of an asteroid that was going to hit the Earth before impact. With time to react and time to predict the location of the impact is very extraordinary. Never seen it before.
It was countdown to impact. With no time to stop this runaway space rock, emails went out to alert those on the ground and in the air. 5:45 a.m. The moment has arrived. A commercial pilot is flying over Sudan. He witnesses a fireball smack right into the Earth's atmosphere with the energy of about 1,000 tons of TNT.
As it entered the atmosphere, it started to burn and brighten. At some point, the stresses on the body became so fantastic from the atmospheric pressure that it just exploded. That explosion would have sounded like a sonic boom.
On the ground, 23 miles below, Sudanese people returning from morning prayers hear the frightening sonic roar. Witnesses see a brilliant fireball, followed by mysterious flashes of light streak across the sky. Scientists had hoped the asteroid wasn't heavy enough to completely penetrate through the Earth's atmosphere and wreak havoc on the ground. Satellites track the fiery explosion, but there is little indication that any fragments survive.
So there is a possibility that people could be frightened by such an event, but the risk of injury is really very low from something so small.
And Steve was correct. There were no reports of injuries or damage due to falling debris in the remote region. Planet Earth was spared from a potential disaster, partly because the region was so remote and the impactor was small. But the story doesn't end here. December 2008. Astronomer Peter Yaniskis organizes a search and recovery team from the University of Khartoum in Sudan. He's determined to find the unlikely: meteorites, the surviving fragments of the asteroid named 2008 TC3.
We had a busload with students who were all eager to go and search. We drove 29 kilometers into the desert to go to the area close to the explosion to look for the smaller pieces that might have survived.
The meteorite hunter's only guide is a map of the Nubian desert with the projected approach path of the asteroid.
They basically used my trajectory and the ground track that I had laid out on the desert floor as a guide for their search.
Lined up everybody about 20, 30 yards apart, and then started walking down the desert in line, searching for things that were black.
But spotting small charcoal-like stones on the rocky desert surface is akin to finding a needle in a haystack. As the sun begins to set on the first day, the team is about to walk away empty-handed when a student suddenly comes forward with a suspicious rock.
A student called Mohammed Alamin had this little rock in his hand that was clearly a meteorite. It had a beautiful black fusion crust around it, and it was undoubtedly a meteorite. And then everybody started being excited and shouting and singing and waving their hands.
280 meteorite samples were eventually recovered, equaling 11 pounds, which for planetary scientists was like hitting pay dirt.
This was one of the meteorites that was recovered. Not much bigger than this. We think that a lot of these meteorites, when they came out of the explosion, were tumbling very rapidly, and that resulted in breaking of the meteorites when it was still up in the air.
2008 TC3 is the first asteroid ever observed in space, which was later found on the ground. Scientists are calling it the first asteroid sample return mission.
It's the first time that we've actually detected something in space, figured out that it was going to hit the Earth, figured out where it was going to hit the Earth, and we actually saw it hit the Earth. We've even recovered pieces of it. That's remarkable.
This whole experience was really fantastic for us. This was an excellent test for what we're really preparing for, which is the possibility of having to deal with a larger impactor sometime in the future.
Planet Earth may not be so lucky the next time. Scientists now suspect 2008 TC3 came from a piece of a much larger rock from the asteroid belt, a region between Jupiter and Mars where asteroids and comets take up residence. In this crowded galactic neighborhood, these fossil relics from the formation of the solar system occasionally collide with each other and explode into smaller pieces. It's these fragments that can migrate towards Earth.
A bullet can provide a pretty good stand-in for one asteroid striking another in terms of its impact speed. Asteroids in the main asteroid belt will run into each other at speeds of over 11,000 miles per hour. Now, a bullet traveling out of a rifle can be a good analogy for that because they will leave a rifle barrel at speeds, maybe a fifth that. So it doesn't just fragment. It literally blows itself to pieces. Okay, we'll head downrange and actually set up our little artificial asteroids at a safe enough distance to shoot. Since real asteroids are hard to come by, we're going to use a couple of stand-ins today.
These bullet impacts are comparable to the collisions in the asteroid belt.
Let's see what our results are here. This is actually rather typical of the results of an asteroid impact, where you tend to have a few large pieces of debris, several medium-sized pieces, but nature is very good at making lots and lots of little debris. These little kilometer-sized fragments are what we actually see today as the near-Earth asteroids, these fragments which have worked their way in from the main asteroid belt, approaching the inner solar system, passing near our planet, sometimes impacting our planet.
These near-Earth objects, or NEOs, have transformed our near-space environment into a danger zone.
The speeds with which objects are running around in the inner solar system is it's much akin to actually a bunch of cars driving crazily down a highway. The vehicles themselves are traveling at high speeds. When they cross lanes without looking and perhaps running into each other, they are hitting at equally high speeds. And that's kind of like objects moving on their own independent orbits around the sun.
Every few hundred years, Earth gets hit with rocks the size of a football field that can destroy entire cities. But every 500,000 years, we get struck with boulders the size of mountains that could ignite global disasters. The Earth's atmosphere, a layer of gases surrounding our planet, incinerates most material. But occasionally, larger, heavier objects slip through.
As soon as they enter the Earth's atmosphere, they get slowed down, decelerated by the atmosphere, and they lose pretty much all of the velocity with which they entered. And during that time is when you see the fireball event. But once they lose that velocity that they came in with, they essentially just fall pretty much at terminal velocity onto the Earth's surface.
When asteroids hit the Earth's atmosphere, they become meteors, bright fireballs in the sky. If they make it to the ground, they're called meteorites. Over the past century alone, meteorites have struck homes, vehicles, and even people. In 1954, an 8-pound meteorite crashed through the roof of a home in Sylacauga, Alabama, and hit a woman in the hip, leaving her with nasty bruises. In October 1992, amateur videos caught a fireball flashing across the skies above several Atlantic states. The 27-pound meteorite eventually crushed the back end of a car in Peekskill, New York. In November 2008, a police dash camera recorded a bright meteorite explosion in the skies over Alberta, Canada. These caught-on-video impacts prove that things really do fall from the sky. What's even more startling is the physical evidence of much bigger impacts, ones that have caused global catastrophes in the past and may ignite a cosmic Armageddon in the future. Earth was not always an ideal address for human beings. During its infancy, 3.8 billion years ago, the third rock from the sun was a cosmic war zone. During this brief period, called the Late Heavy Bombardment, billions of leftover debris from the formation of the solar system pummeled our planet at rates up to 20,000 times higher than today.
What happened is that Jupiter and Saturn, the two giant planets in our solar system, went into what's called a gravitational resonance with one another. So Jupiter made 2 complete orbits around the sun for every single orbit made by Saturn. And when that happened, it rearranged the entire solar system. It reshuffled Uranus, Neptune, Jupiter, and Saturn, and moved the giant planets farther out. When that happened, that just sent a volley of comets and asteroids rocketing into the inner solar system.
At the same time, these rocky bodies helped to mold our baby planet to the shape it is today. Here are the battle scars. Only 170 impact craters are still visible on Earth. Weather, water, and plate tectonics have erased most traces of ancient cosmic violence. But proof of Earth's tumultuous past lies on the Moon, which was formed at the same time, but lacks plate tectonics and other erosion processes that tend to erase the evidence.
The Earth itself has been bombarded every bit as much as our nearby moon. If you look up at the moon in the sky and you see its cratered surface, you have to imagine our own Earth cratered and battered to at least that degree, and in fact, because we're a bigger target in space, even more.
By counting craters on the moon, scientists can learn about the number of impacts on the nearby Earth, past and present.
Scientists can learn about the sizes and compositions of asteroids that impact the Earth by studying the characteristics of the craters that they create. So we're going to try and demonstrate that today by tossing some weights into the sand on the beach here, and we're going to see if we can come up with a relationship between the size of the weight and the size of the crater that it creates. based on my measurements, I calculate that this beach was impacted by 3 rocks 10 inches in diameter, 5 rocks that were 6 inches in diameter, and 11 2-inch diameter rocks. This technique of measuring the size and frequency of craters on this beach is very similar to the technique that scientists use to understand the frequency of impacts throughout Earth's history.
Today, the best preserved impact craters exist in dry desert regions around the world. Meteor Crater, located near Winslow, Arizona, is one of the lasting reminders of the destruction caused by objects from space. And scientists are just cracking the surface of understanding the repercussions of these ferocious events.
Okay, lights.
Okay, did we want to back one off to 250,000?